Okay, welcome back. This is Matrices objective number 3. We're dealing with multiplicative identities and inverses. If you have a matrix times another matrix, and so if A times a matrix is equal to A, then this I matrix is the multiplicative identity. Now, it could also be on the other side, possibly it could be I times A equals A, then it's still the multiplicative identity. It works either way. Remember that multiplication with matrices is not commutative. Okay, so let's go ahead and try that now. So if I have these two matrices that I'm multiplying, this is a 2 by 2. And this is a 2 by 2, and we can see obviously that we can do that. And so we get a 2 by 2 resultant. Okay, so first row, first column, we get 3 plus 0. And second row, first column, or second row, first row, second column. Let me get it right. First row, second column. So we get 7 plus 0. Second row, first column, we get 0 plus negative 1. Second row, second column, we get 0 plus 4, which obviously becomes 3, 7, negative 1, 4, which we can see that that one is the same as this one right there. And so therefore, this is a multiplicative identity. And so yes, a multiplicative identity looks like in this form. The main diagonal is positive 1s. The main diagonal starts at the upper left and it goes to the lower right. All of those are positive 1s. All the remaining elements are zeros. Okay, so let's try this one right now. This is a 3 by 2. This is a 2 by 2. So yes, it is possible, and the resultant will be a 3 by 2. Okay, so 5 plus 0. Let's see. 0 minus 6. Okay, second row, first column. So 2 plus 0. Second row, second column. 0 plus 3. Third row, first column, negative 1 plus 0. And third row, second column, 0 plus 4. And again, those two are the same. So multiplicative ID right here. What you will find is the multiplicative identity is always in this form where the main diagonal is positive 1s, all the remaining elements are zeros. So for example, if we have a 3 by 3, main diagonal, all positive 1s, and all the remaining elements are zeros. If you have a 4 by 4, same thing. Main diagonal is all positive 1s, and all the remaining elements are zeros. Okay, so if A is invertible, in other words, if you can find an inverse for the matrix A, because you can't always, not every matrix is invertible, okay? But if it is invertible, then a matrix times its inverse will equal the identity, the multiplicative identity. Okay, so keeping that in mind, given that B is this matrix, we're solving for A. Okay, so this is B. B times A is equal to this make that a little bit better for this matrix. Okay, now we did some algebra with when we were doing matrix addition, subtraction, and scalar multiplication, but that much easier. Because you might just look at this, you might say, okay, oh, well, let's just divide by the matrix. There is no such thing as matrix division. Okay, but what we can do is, because this is matrix B, if I can find the inverse of B, I can multiply by B inverse. Okay, now I'm multiplying the left side by B inverse, which means over here on the other side of the equation, I must multiply on the left side by B inverse as well. So be very careful with that kind of stuff. Now, B inverse times B will give me the identity matrix. And the identity matrix times A is equal to A. And the way that we get that then is we're going to do B inverse times that matrix. Okay, so now we just have the little thing of finding the inverse function. Okay, so how do we do it? Now, there are ways to do it, particularly for 2x2s without this method, but when we get to more dimensions, like 3x3, we have to use this method. And so we need to practice this method. And the method is by row operations. Okay, so by row operations, we're going to do a little bit of scratch paper off here to the side. What we're going to do is we're going to write the matrix B, 3, 5, 1, 2, and then technically it's a little dotted line right there. And then we're going to write the multiplicative identity that matches up to this. And by the way, the multiplicative identities are always square matrices. So, but 1, 0, 0, 1. And through row operations, we are going to convert the left side to become the multiplicative identity. So it's going to become 1, 0. Sorry, the lights will come back in just a minute here. The left side is going to become the multiplicative identity. So the main diagonal, all ones, and everything else zeros. And through the row operations, the right side will become the inverse. Okay, so now we need to start with the upper left-hand corner. The upper left-hand corner must be a positive 1. And yes, we can multiply by 1/3, but try to avoid fractions as long as possible. And so what I'm noticing is if I multiply the bottom row by -2 and add it to the top row, -2 times 1 will get me -2 plus 3 is 1. Okay, now the bottom row is not changing. Let me write a little bit bigger here. 1, 2. By the way, the dotted line kind of drives me nuts, so I just do a vertical line usually. 0, 1. Okay, now I'm doing -2 times 1. -2 times 1 is -2 plus 3 is positive 1. And then -2 times 2 is -4 plus 5 is positive 1. And -2 times 0 is 0 plus 1 is still 1. And -2 times 1 is -2 plus 0 is -2. Okay, so that's a good first step. So we got the top left corner to be the positive 1. Next, you get the zeros beneath it. Get the zeros beneath it. Okay, and so what I'm going to do is I'm going to multiply the top row by -1 and then add it to the row below. Now, the top row is not changing, so I'm going to go ahead and write it again. 1, 1, 1, -2. And I'm multiplying the top row by -1 and adding it to the bottom row. So I get -1 plus 1 is 0. And then I get negative 1 plus 2 is 1. And that's really nice, and I'll explain why in a minute. And then I get negative 1 plus 0 is negative 1. And then I get 2 plus 1 is 3. Okay, so it's coming along. So I got my top left 1. I got the zeros beneath it. Then I get the next 1 in the main diagonal. Remember I said it was really nice? Well, we got the positive 1 and the next 1 in the main diagonal. So we already have that. Lastly, you get the zeros above it. You get the zeros above it. Okay, so I'm going to multiply the bottom row by negative 1, and then I'm going to add it to the top row. So the bottom row is not changing. So 0, 1, negative 1, 3. So negative 1 times 0 is 0, plus 1 is still 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times negative 1 is 1, plus 1 is 2. And negative 1 times 3 is negative 3, plus negative 2 is negative 5. Okay, so now the left-hand side is the multiplicative identity. The right-hand side is the inverse we were after. Okay, now some of you might be saying, well, if it exists, how do we know if it doesn't exist? If as you're going along and you're not making any mistakes, if you get a row of zeros, just over here on the left side, if you get a row of zeros or even a vertical column of zeros, then you can't find the inverse. The inverse does not exist. But anyway, we were successful here. So this is B inverse. And so we're going to be doing B inverse, which is 2, negative 5, negative 1, 3 times 4, negative 2, 3, 7. And that's what A is equal to. So now we still need to do that. So let's see. I've got 8 plus negative 15. I've got negative 4 minus 35. I've got, notice I like using my fingers to keep track of stuff. Negative 4 plus 9. And I've got 2 plus 21. And so A is negative 7, negative 39, 5, 23. Okay, so now it's definitely a lot more complex. The doing the when you're doing algebra and having to involve yourself with inverse functions. Okay, now this was that was a pretty easy inverse function to do. And our focus really is on inverse functions. I'm going to do 2 that are much more challenging. One more 2 by 2, and then also a 3 by 3 because we have to be able to do the 3 by 3s as well. But we need to get better at these before I tackle the 3 by 3. Okay, moving on. Problem number 4 here. Now this it's another 2 by 2, but this one's definitely more challenging than the first one we did. Okay, but we already have an idea of how to set things up. Okay, so here we go. We got 4, negative 2, 3, 7, and then the identity matrix over here on the other side. Okay, so I think I would multiply the bottom by negative 1 and add it to the top so we get that positive 1. In the upper left part of the main diagonal. So the bottom row is not changing. Okay, so -3 plus 4 is 1. -7 minus 2 is -9. 0 plus 1, -1 plus 0. Okay, so that's good. We've got the 1 up there, and now I think I would multiply that top row by -3 and add it to the bottom row so that I get the 0 beneath it. Okay, now the top row is not actually changing. 1, -9, 1, -1. Okay, so we get -3 plus 3 is 0. We get 27 plus 7 is 34. We get -3 plus 0, and we get +3 plus 1. Okay. Now, we've got the top left one. We've got the zeros beneath it. And then we get the next one in the main diagonal. And now, because it's just a 2 by 2, the next one in the main diagonal also happens to be the last one in the main diagonal. So if you've been able to avoid fractions all the way to here, if fractions are going to happen, this is where you won't be able to avoid them any longer. And so, because really the only way to get it to be a positive 1 is to multiply through by something so that it becomes a positive 1 right there. So in this particular case, we're going to multiply through by 1 over 34. Top row is not changing. So 1, -9, 1, -1. And the bottom row, we get 0, 1, -3/34, and +4/34. Yes, reduce. 4/34 is 2/17. 2/17. Okay. So now, now that bottom row right there, that's the bottom row of the inverse matrix, by the way. Last thing we need to do is we need to get the 0 above that last one on the main diagonal. And so if we multiply the bottom by 9 and add it to the top, we'll get that. Now the bottom row is staying the same. Okay, so the top row, we get 0 plus 1, 9 plus -9. Okay, that's the easy part. We get -27/34 plus 1. Now, you might need to have a little bit of scratch paper going somewhere, but you might be able to just do it in your head, but make sure you do it correctly. So -27/34 plus 34/34. So 34 minus 26, so 7/34. Okay. And then we get 18/17 minus 1. 18/17 minus 17/17 is 1/17. Okay, so now we have the identity matrix over here on the left. That means that this is the inverse of M. So this part right here is inverse of M. Okay, now all of this has been building up to doing a 3 by 3. And so I've got it all set up. Double check to make sure you wrote the matrix down correctly, and also the identity matrix correctly as well over there. Now there is one more thing that we can do that I did not tell you about when we were doing the 2 by 2s, and I'm going to go ahead and tell you about it right now. It is possible for us to move rows up or down. Now, don't do that until you've actually set up the problem, because if you're going to move a row up or down, you can't move it up or down in the original matrix. But once you get it all set up with the identity matrix over here to the right side, if you move a row up or down, then the right-hand side of it has to move up or down with it. Now, why am I pointing that out right now? Well, for one thing, it's another tool that you can use. And now, you can do all of these without doing that sort of thing, but it could make your life a little bit nicer. And for example, I'm noticing in the bottom row, the left-hand element here is a 1. So we could move this bottom row up to the top, and we'd have our positive 1 in the top left-hand corner of the main diagonal already. We don't have to do it that way, but I think I'm going to go ahead and do it that way just so we have an example where we do that. So I'm just going to switch the bottom row and the top row. Okay, so now I have my positive 1 in the top left-hand corner of the main diagonal. So next we get the zeros directly beneath it. Make sure that you go in this order, otherwise you undo things that you've already fixed and all that kind of stuff. So now I would multiply the top row by -3 and combine it with the middle row, because that would get me a 0 here on the left-hand side. And I can even do this on the same step. I can multiply the top by 4 and combine it with the bottom row to get that 0 right there. Okay, so now the top row itself is not changing. Okay, so negative, and don't be in too much of a hurry, because a little mistake can turn into an avalanche. So I get -3 plus 3 is 0. -12 minus 2 is -14. -9 plus 1, -8. 0 plus 0, 0 plus 1, -3 plus 0. Okay, and now I'm multiplying the top by 4, and then going to combine it with the bottom row. So 4 plus -4, 0. 16 plus 5, 21. 12 plus 2 is 14. 0 plus 1, 0 plus 0. 4 plus 0. Okay. We've got the top left-hand corner, the 1, and then the zeros beneath it. Next, we want to get the next 1 on the main diagonal. Now, I'm looking at the numbers here. -14 and 21, that would be quite challenging to work with them and get a positive 1 in the next. I mean, it could be done. It can be done, definitely, but quite challenging. We could multiply the whole row by -1/14, and we'd get a positive 1. But here's another thing that we could do. I'm noticing that, 14 and 21, they both have a common factor of 7. So if I multiply each row by 1/7, effectively, I'm getting these numbers out in front a little bit smaller, easier to deal with. Yes, I'm going to get some fractions started. I promise you fractions are going to happen in this problem anyway. Top row itself is not changing. 1, 4, 3, 0, 0, 1. Okay, I get 0, -2, -8/7, 0, 1/7, -3/7. And then I get 0, 3, 14/7 is 2, 1/7, 0, 4/7. Okay, now looking ahead, that looks much nicer. So in fact, I'm recognizing if I multiply the bottom row by 1 and combine it with the middle row, I will get a positive 1 right there. Okay, so I like that idea. The top row is not changing, the bottom row is not changing. So 1, 4, 3, 0, 0, 1, 0, 3, 2, 1, 7, 0, 4 sevenths. Okay, so I get 0 plus 0, 3 plus negative 2, 2 plus negative 8 sevenths. So 14 sevenths plus negative 8 sevenths is 6 sevenths. 1 seventh plus 0. 0 plus 1 seventh. 4 sevenths plus negative 3 sevenths. And that's kind of odd, getting 1 seventh all the way across over there. Okay, but we've got the top left one and the zeros beneath it. I've got the next one in the main diagonal. I need to get the 0 beneath it. And I recognize that if I multiply the middle row by negative 3 and combine it with the bottom row, I will get 0 down there. Okay, so top row and the middle row are not changing. 1, 4, 3, 0, 0, 1, 0, 1, 6 sevenths, 1 seventh, 1 seventh, 1 seventh. Okay, 0 plus 0. Negative 3 plus 3. Negative 18 sevenths plus 2. Negative 18 sevenths plus 14 sevenths. Negative 4 sevenths. Negative 3 sevenths plus 1 seventh. Negative 2 sevenths. Negative 3 sevenths plus 0. Negative 3 sevenths. Negative 3 sevenths plus 4 sevenths. 1 seventh. Okay, moving on. Now we need to get the last one on the main diagonal, and really the only way to get that is to multiply by its reciprocal. So multiply by negative 7 fourths. Top two rows are not changing. 1, 4, 3, 0, 0, 1, 0, 1, 6 sevenths, 1 seventh, 1 seventh, 1 seventh. Bottom row, 0, 0, 1, positive 2 fourths, which is 1 half. Positive 3 fourths. Negative 1 fourth. And I'm running out of paper down here, so I'm going to move up. But even as I'm moving up, what's the next thing we're going to do? Well, we've got all the ones on our main diagonal, and we also have the zeros beneath the first one on the main diagonal and the 0 beneath the second one on the main diagonal, and now we've got the last one on the main diagonal. So now we need the zeros above, but it matters the order. So just so you don't undo some things that you're working hard to get, you need to get the zeros above that last one on the main diagonal first, and then the very last thing you do is you get the 0 above the middle one on the main diagonal. So I'm going to multiply the bottom by negative 6 sevenths and combine it with the middle row. And I'm also going to multiply the bottom row by negative 3 and combine it with the top row. Now, the bottom row is not changing. The only one that's not changing. So 0, 0, 1, 1 half, 3 fourths, negative 1 fourth. In fact, as long as we've done everything correctly, that's going to be the bottom row of the inverse matrix. Okay, now let's do the top row first. The top row is going to be easier. So 0 plus 1, 0 plus 1 is 1. 0 plus 4 is 4. Negative 3 plus 3 is 0. Okay, now the hard work begins. Okay, so negative 3 halves plus 0. Okay, well, it's actually not that hard yet. So negative 3 halves plus 0, which is negative 3 halves. Negative 9 fourths plus 0. Negative 9 fourths plus 0, which is negative 9 fourths. And positive 3 fourths plus 1. Positive 3 fourths plus 1, so 7 fourths. Okay, middle, we're going to multiply the bottom by negative 6 sevenths now and add it to the middle row. 0 plus 0. 0 plus 1. Negative 6 sevenths plus 6 sevenths. Okay, all those are the easy ones. Now we got our work ahead of us. Okay, so we got negative 6 sevenths times 1 half. So that would reduce. I would get negative 3 sevenths negative 3 sevenths plus 1 seventh. Okay, that's not too bad. That's negative 2 sevenths. Okay, negative 6 sevenths times positive 3 fourths. Okay, so that's negative. Okay, let's see, the common factor of 2, so negative 9 fourteenths plus 1 seventh, so plus 2 fourteenths, that's negative 7 fourteenths, which reduces to negative 1 half. Last one, negative 6 sevenths times negative 1 fourth, so it's positive, common factor of 2, so positive 3 fourteenths plus 1 seventh, so plus 2 fourteenths, sorry. 1 seventh is 2 fourteenths, so 5 fourteenths. Okay, I think that's probably about the hardest row. The only thing we have left to do now is to get that top middle term to become a 0. Sorry, we lost the audio for the last bit of solving. So picking up where we left off, we're going to be multiplying the middle row by negative 4 so that I can get a 0 in the top row there in the middle. Okay, so negative 4 times 0 plus 1 is 1. Negative 4 plus 4 is 0. Negative 4 times 0 plus 0 is 0. Okay, well, obviously that part is very simple, but just check and make sure that it's actually working out correctly. Now we get to the harder part. Okay, so negative 4 times negative 2 sevenths is positive 8 sevenths plus a negative 3 halves, so minus 3 halves. Okay, so that would be 16 minus 20, so negative 5 fourteenths. Okay, and -4 times -1/2 is +2. -9/4, well, that's not hard. 8/4 minus 9/4 is -1/4. Probably didn't need any scratch work for that one. Okay, last one, -4 times 5/14. So, okay, common factor of 2 there. So let's see, that's -10/7 plus 7/4. And so common denominator of 28. And so that's going to be 9/28. Okay, now, excuse me, as long as we've done everything correctly, this is going to be a inverse right here, this part right here, not the whole thing, but just this part over here on the right-hand side. And I do have it worked out from earlier, so let's compare to see how we did. And so if we look, -5/14, -1/4, 9/28, -2/7, -1/2, 5/14, 1/2, 3/4, -1/4. So yes, yay. Don't be in a huge hurry as you are working on these 3x3s particularly. Use some scratch paper as needed. Go forth and conquer.